Dr. Robert Zubrin, the thought leader and founder of the Mars Society, has developed a plan called Moon Direct that applies his Mars Direct ideals towards the moon. It takes advantage of the currently cheaper available rockets from commercial rocket companies to get us there sooner, cheaper, and at lower risk. Hi, my name is Matt Warren, and I am the host of Moon to Stay, a show dedicated to exploring the moon. In this episode, you'll learn all about the Moon Direct plan, a low-cost and rapid and sustainable vision for getting back to the moon proposed by Dr. Robert Zubrin. If you want to connect with me, I'm on Twitter, Matt_Warren, and the show notes are available on my website, mattwarren.co. Dr. Robert Zubrin is best known for his Mars Direct plan, initially proposed in 1990 and later expanded on in his book, The Case for Mars, which was published in 1996. In Mars Direct, Zubrin proposes a series of rocket launches to place key pieces of technology on Mars in advance of a manned mission, starting with the launch of a return vehicle and the fuel production equipment, followed by launching habitat modules, and then a bare-bones contingent of astronauts. By living off the land and taking some risks, Mars Direct would put people on Mars quickly, mostly with existing technology. Zubrin's approach could be summarized as, if you want to go to Mars, just focus on doing that. With the excitement building around lunar exploration and development again, he has taken this same direct approach strategy and developed a plan for getting to the moon. Zubrin dislikes the NASA plan to build a lunar orbital platform and gateway called the LOP-G.
In my view, the requirements for a highly effective lunar exploration program is maximum access to the lunar surface, minimum development and recurring cost, minimum schedule, and minimum risk. Okay, now this is exactly the opposite of what we're seeing in the program of record right now with the Lunar Orbit Gateway, in which you have minimum access to the lunar surface, maximum development and recurring cost, maximum schedule, and maximum risk.
The gateway reduces scheduling flexibility, since the unusual orbit proposed would have launch windows every 2 weeks rather than continuously. And the rendezvous in lunar orbit will add fuel costs to every mission that uses it. Instead of building a small space station in lunar orbit, Zubrin would prefer to skip directly to build the moon base itself. The NASA Lunar Gateway will be a small space station in orbit around the moon. It would be placed in what's called a near rectilinear halo orbit, which would make it accessible to a large percentage of the lunar surface for possible missions. It's not like the ISS. The gateway is designed to be left vacant for most of the time. You could think of it as a very expensive garage to park a lunar lander. It's designed as a waypoint between the Earth and either the Moon, Mars, or deep space. It would be inhabited only while there is an ongoing mission on the Moon, and it wouldn't be suitable for long-term stays. On its own, the station doesn't provide much scientific value that can't be had on the International Space Station. Indeed, since it's exposed to cosmic radiation, For safety reasons, human use of the station would be kept to a minimum. With 1 or 2 lunar missions per year, the gateway would be vacant for more than 90% of its lifetime. And with the SLS being the only launch vehicle capable of getting humans to lunar orbit, each mission would be estimated at $2 billion. That's fairly difficult to sustain. Instead, Dr. Zubrin suggests that if we want to go back to the moon, we should just start by going there directly and build that moon base on the surface. There's real value to being on the surface from a scientific and an operational and from a safety perspective. Cosmic radiation exposure at the LOP-G station can be mitigated on the moon by burying or digging into the surface and using lunar material as a shield. The scientific work about the moon mostly needs to be done on the moon. Who figures? So putting the resources into orbit is really investing in the wrong place. And operationally, the ability to mine lunar water is the potential game changer that makes local lunar transport feasible. It reduces the ongoing cost to maintain the base and would ultimately make the moon a reasonable place to stop on the way into deep space to refuel. The Moon Direct mission makes use of SpaceX rockets to cheaply deliver payloads to the surface of the moon, and it operates in a 3-phase process.
The first phase is we're going to pre-place some cargo, some habitation modules, a power system, things like that on the moon. These are unmanned missions. They go one way from the surface of the Earth to the surface of the moon. Okay. The second phase are initial piloted missions, okay, to the moon. They go to this base. And they are distinguished from what follows because in these initial missions, it is assumed that in situ propellant is not yet available. So these missions are being flown without that ability. Then in phase 3, once they make ISRU available, or ISPP, in situ propellant production, we can do recurring piloted missions with the assistance of in situ propellant.
To start, Falcon Heavies would land a 10-ton habitat module or modules and supplies on the surface of the moon. Falcon Heavy is not rated for human transport, so all of these initial supply missions would be robotic deliveries with a goal of providing the hardware required for the subsequent missions. Zubrin suggests that the most appropriate place for a moon base is at one of the poles, where there is evidence for ample water and perpetual sunlight for solar power. With the first phase of delivery missions complete, we would then move on to the next step. And in that second phase, we would get humans to the moon. They would continue with construction and assembly of those previously launched pieces of equipment and establish the production of hydrogen fuel. The Falcon 9 does not have the thrust required to reach the moon directly with a crew, so getting astronauts to the moon without using the expensive SLS requires some creativity. Moon Direct tackles this by suggesting a pair of launches. Start by launching a fueled lunar lander called the LEV into low Earth orbit. This lunar lander vehicle would be operated as a cislunar transport vehicle that ferries people from low Earth orbit to the lunar surface and back again. The LEV launch would be followed by a manned Dragon capsule. The Dragon capsule and lander will meet in low Earth orbit, and the crew will transfer from the lander to that lev and leave it behind as they proceed to the moon. This rendezvous could be directly between the lev and the capsule, but it also could happen at the International Space Station. During this second phase, without production of hydrogen on the moon, we would have to launch that fuel ahead of time in that lev. One of the key insights here is that by not flying the Earth re-entry vehicle, the Crew Dragon, all the way to the lunar orbit, there's a massive savings in mass and fuel. Bringing parachutes and heat shields and all the rest of it to the moon is kind of unnecessary. So those things are left in low Earth orbit. The final phase of the plan would be to start using that electrolyzed lunar water to fuel the lunar lander vehicle. This would eliminate the need to launch additional fuel into space and would power the cislunar transit of people and supplies from Earth orbit to the moon and back. It would also power the lunar lander on hops around the moon to access areas of interest, and significantly reduce the costs of future missions to the moon. Most of the technology for making this moon direct strategy real already exists or can be quickly developed based off of existing hardware. The new technology for this mission is an updated hydrogen-fueled lander exploration vehicle to land and take off from the moon. The Apollo lander was a one-time use vehicle. The landing legs were left on the surface of the moon, so for this mission we would need something fully reusable and single stage. The other things to design, such as a habitat module suitable for the moon gravity, would be relatively straightforward engineering. This three-phase direct approach to the moon has a lot of things going for it. It gets humans back to the moon quickly. It builds a base that has real operational and scientific value. It would contribute to lowering the ongoing costs of transiting to the moon. It leverages the low-cost SpaceX rockets and other commercial rockets rather than expensive SLS, while being flexible for using Soyuz or other providers as well. It has scheduling flexibility. You can launch at any time to or from the moon. It lowers the human risks from cosmic radiation exposure compared to the LOP-G gateway station. And it lowers the liability as a result and the maintenance cost of that LOP-G station. Also, it allows for longer term or permanently manned presence on the moon. It's worth taking a quick moment to break down the costs to compare the LOP-G with the Moon Direct plan, because there is a massive difference. If we assume that the gateway platform hardware would be roughly the same cost as the initial lunar base facility, then the difference really comes down to the launch costs and the ongoing maintenance costs. LOP-G would likely require 3 or more SLS launches at approximately $2 billion each to get the major components into lunar orbit. Ongoing Orion SLS missions for humans would be an additional $2 billion each. Let's say that's about $8 billion or more to the cost to build that station up initially. The Moon Direct plan uses Falcon Heavy rockets at $150 million each, launch per launch, and the Falcon 9s at $70 million each. With two launches, we could get 16 tons, which should be enough to get started in the first phase. A pair of launches then with the Falcon Heavy to launch the fueled LEV, followed by a Falcon 9 with the Dragon crew, would be about $220 million per launch to get the construction done. We might need 2 of those launches. That should put the necessary hardware and people in space for a total assembly cost of about $470 million. This is a massive savings over the LOP-G, at approximately 1/10 the price to get established. Ongoing costs make this difference even wider. SLS Orion missions to the moon will continue to cost $2 billion each or so, and Moon Direct will require just a single Falcon 9 launch at $70 million, plus a minor cost for the LEV transit using hydrogen from the moon. That works out to perhaps 1/25th the cost, or less than 10%. Furthermore, LOP-G missions would be capped at 2-week durations for the rendezvous windows, and a lunar base on the surface could be inhabited for many months at a time. That multiplies your scientific and operational value that you get out of it. Dr. Zubrin estimates that the total cost of the Moon Direct plan, including the base and the launches, to be an initial $1.5 billion for the Phase 1 and 2 missions, plus ongoing $420 million per year for 3 human missions, which would swap out the crews and resupply the base. This is a real bargain compared to LOP-G, and well within the existing NASA budget for human spaceflight. This, to me, seems like a very practical plan for NASA to consider. Thank you all for listening to this episode of Moon to Stay. I hope you learned something. Please tell a friend about the show. Also, like, share, subscribe, comment, or leave a review. All these things help me grow and improve the show. You can reach me on Twitter at Matt_Warren and get show notes for each episode on my website, mattwarren.co. Now that you've finished this episode, go back and check out some of our previous episodes. New episodes are published every Friday. Stay tuned until then, and keep looking up.